All right, thanks to everyone who's joined us today. We're excited to focus on the OWASP Mobile Top 10 risks. As a reminder, the OWASP Mobile Top 10 is a key building block that we want security teams to check off their list when using our mobile app security testing solutions. We remind everyone that the list is ever evolving to meet the rapid speed of mobile innovation. The community has plans to update its guidelines this year in 2016 specific to mobile. And we always remind folks that while the mobile threat landscape extends well beyond the categories here, we recognize their value in focusing on securing mobile app data, connecting to outside servers, handling sessions properly, and more. As I mentioned, my name is Keith Mokris, the Product Marketing Manager here at NowSecure, and I'm excited to be joined by Katie Stremka. Many of you might know Katie, who leads our services team, and that team focuses on third-party auditing and certification services for a wide range of enterprise clients and use cases. Welcome, Katie, to the call.
Thank you, Keith. As we cover each of OWASP mobile risk categories with you guys today, I'm going to be chiming in with some examples that I see in real apps every day when we do our testing. As you guys may know already or will learn, OWASP is really a great list to continually reference when you perform your app testing, and we actually do map to these guidelines as well in all of our app testing products and services. When you're testing a mobile application, the key is to really make sure that you're covering the entire mobile attack surface, as we like to call it, and I like to generalize these into four main categories: forensic analysis to recover insecure data at rest, network analysis to ensure data is encrypted in transit, web services and back-end testing to ensure your data on the back end is secure, and then reverse engineering and code analysis to identify weaknesses in code implementation. OWASP tends to break these down even further, so into the top 10, and that's what we're going to be walking you guys through today. Next slide. So the first is improper platform usage. Keith, if you go ahead and move forward. This improper platform usage really focuses on the misuse of a platform-specific feature or lack of platform security controls for the Android or iOS operating systems. So we give the examples here of issues that may include incorrect use of the keychain that's specific to iOS or Android intents. But one example that I'd like to focus on that we don't have up here is actually data on iOS that's stored by default by the platform in the caches directory. This is an extremely common issue that we see in many apps. If the app developer doesn't specifically disable this, the platform will automatically cache some app data into a SQLite database that's stored in that app folder. That's one example, which I guess could arguably fall under this or insecure data storage, but it's a key thing to focus on when trying to avoid insecure data at rest. And so the best practices that you're looking at here are really just two examples that we have that relate to platform-specific issues. The first is improper implementation of Android intents, which could lead to things like data leakage or manipulation of program flow. And the best practice when you dive into it further talks about using public versus private components and just basically making sure these intents are properly implemented to avoid these issues that we talk about. The second one here is using the iOS keychain carefully. As you guys probably know, iOS provides the keychain for secure data storage. However, in several scenarios, the keychain can be compromised and subsequently decrypted. So this best practice offers some techniques to ensure that the keychain remains secure. The next one that we have here is insecure data storage. And we say these are vulnerabilities that leak personal information and provide access to hackers. It's really unrealistic to assume that no app is going to store data. We realize that in many, if not most cases, data must be stored somewhere. So the question is, where is the most secure? Depending on the platform, there are a number of places where we find app data stored, whether it's in the private app folder, system log files, keychain, SD card. The number one thing to avoid is storing that sensitive data in a place that another app or an individual could get access to. So places such as the SD card or system log should definitely be avoided. but even the iOS keychain, as we just mentioned, which can be a secure form of data storage if done properly, can also be compromised using certain tools. Last year, we tested over 400,000 mobile apps and found that 1 in 4 have at least one high-risk security or privacy flaw, and over 10% are actually leaking sensitive data in plain text. So while a mobile app has a high-risk issue, it compromises user information, communications, or file system abilities, and these issues around sensitive data are really important to focus on and to avoid. 3 out of 4 consumers use duplicate passwords across accounts, so things like leakage of passwords for one app could just trickle into other issues for that particular individual across the board. The 2 best practices that we've highlighted for this particular category talk about where and where not to store data, as well as how to do it the most secure way possible. So the first one listed here is, it seems generic, but we do get into a lot of details as you click through that link. So it covers things like recommended encryption methods, as well as data protection APIs on iOS, for example. The second best practice we have here is very specific to app data that's left in memory. So when a user is signed into an app and we're testing it, it's really not a surprise for us to see that app data temporarily be stored in memory. However, the key is to remember that when the user signs out of the app or the session times out, the expected behavior is that all of that sensitive data is cleared as it's no longer needed. So here we cover some ways, in this best practice, we cover some ways to nullify any variables that hold those keys after use. And now Keith's going to be talking to you about insecure communication, I believe.
Yes, that's right. So that's the next risk identified by the OWASP Mobile Top 10. And insecure communication refers to communications being sent in clear text, as well as insecure methods. And this is one of the most important issues to check for, because issues involving the network traffic and insecure communication generally carry higher risk or higher CVSS scores due to the remote nature of these attacks. And one of the things I'm going to show in an upcoming example actually combines the next 2 risks to illustrate the severity of insecure communication. Here's one of the best practices, which seems pretty straightforward when it comes to implement secure transmission of sensitive data. And so today, best practices call for app providers to use SSL or TLS effectively to secure the transmission of passwords, login IDs, and other sensitive data over the network. And they can even go further and leverage app layer encryption to protect user data. And the example we're going to be talking about piggybacks off of OWASP Mobile Top 10 risk number 4, insecure authentication. Insecure authentication can refer to the process of verifying who you are when using the mobile app. So when you log on to access data, your username and password is what you're authenticating. And so we have a best practice here that refers to tokens and account numbers when using a mobile app. And obviously that's something that seems very straightforward. And unless there's a need to store the complete number on the device, storing partially hidden numbers makes good sense there. And in that best practice, we have a lot of examples around that. But the example I'd like to share talks about how a mobile app failed to secure communication, but then also led to authentication issues. So the example I have here today is Ola Cabs. And so Ola Cabs was Uber's biggest competitor in India with over 150,000 bookings a day via their mobile app. And in this scenario, a hacker used MIDM proxy to view API calls over simple HTTP, so insecure communication. Using these calls, they showed that there wasn't an OAuth token mechanism or any other encryption to guard the APIs. And so the hacker made several transactions to see the data that was sent and quickly found that he could reuse his original order ID to endlessly gain access to unlimited free rides. And this is a perfect example. We link to a source here on the next web, so we'll share these slides when we're done with the webinar. And the hacker recalls all the steps that went into him gaining access to this attack.
So the next one here on the list is insufficient cryptography, which we break out and highlight two types of flaws in this category that can lead to an adversary gaining access to sensitive information from a mobile app. The first, the process behind encryption and decryption may allow a hacker to decrypt that sensitive data. And second, the algorithm behind encryption and decryption may be weak in nature. So in our app testing every day, we've actually seen apps that attempt to encrypt all user data in a database, but then they'll do something like store the static encryption key somewhere that can be easily accessible and used to decrypt that data. If encryption's implemented poorly, in some cases, developers are almost better off just relying on the Android and Apple's platform data protection. So it's really important that if you're going to do it, make sure that you do it right. That leads us to a couple of the best practices, or I'm sorry, one best practice that we have listed here, which gives some recommendations on how to do this. So as discussed in the best practice when you link to it, if you're going to add encryption layers to protect your app data, we recommend avoiding custom encryption methods unique to your application and instead using well-known proven encryption algorithms and methods. This could include using SQL cipher with a pragma key to store data in a SQLite database. But the other key thing to remember is to always use randomly generated master keys that are different from one device to another. This is opposed to a static key that, if retrieved or accessed in some way, could be used to compromise many users' data as opposed to just that one. So randomly generated master keys and then using well-known or proven encryption methods and algorithms is absolutely a recommendation in this area. The next one we have on the list is insecure authorization. And so as opposed to authentication, which Keith just talked about, authorization is the process of verifying that you have access to something. So gaining access to a particular resource because of certain permissions that are configured. Certain permissions that are configured allow you access as authorization. So basically, not are you who you say who you are, but do you have access to the resources that you should as that particular user? So if your application that you're developing or that you're testing allows access to different resources based on the type of user that's logged in, it's really important to run a number of tests to ensure that it's not possible to transition from that basic user mode to admin user mode, for example. When we test client applications, we do run a number of privilege escalation tests, both on the client and the server side. So one of the best practices that we have listed here, this is really just one of a few that we have authorized authorization. But whether it's properly configuring your web server to avoid information disclosure or using techniques to properly manage user sessions, this in general is an important step to securing your user and app data.
Great, thank you, Katie. The next issue we're going to be talking about is client code quality, number 7 here on the OWASP Mobile Top 10. And client code quality can refer to risks that come from vulnerabilities like buffer overflows, format string vulnerabilities, and various other code level mistakes where the solution is to rewrite some code that's running on the mobile device. And we actually have a really good example of this from NowSecure researcher Jake Van Dyke. And he's published this research on the blog, which we'll then link to. But the example he used here involved a third-party code library called the Vitamio SDK. And this is used in thousands of mobile apps. And popular developers using this SDK have between 10 million and 50 million downloads, and even a few as high as 180 million. And the problem is, when the Vitamio library is initialized, it creates a world writable directory and then extracts its payload of several native libraries into this directory with world writable permissions. And so Jake Van Dyke, who's talked about this before in other webinars, outlined how you can pick an app that uses this library and then swap out one of its native libraries with our own and cause it to run our own code. And he outlines how you should test those third-party libraries. Another thing that we've discussed is there's an informal poll on one of our favorite websites that asked mobile developers how many third-party code libraries they use when building applications. and responses ranged from 3 to 5 to 8, but Katie actually has a story about how some apps we've tested use even many more than that.
Yeah, I just wanted to add a little bit more color around this based on real-world examples that we see in testing apps every day. There was a particular application that we were looking at that actually used between 20 and 30 different third-party libraries and SDKs, and it was just kind of a compilation of third-party code that was, wrapped in this one app. And in doing our testing, we found a high-risk man-in-the-middle vulnerability in one of the components, which was actually not owned by, the person that hired us to do the testing. And so this was an issue in the third-party developer's SDK that was being used, and this customer had no control over it. So it's one thing to be careful about which SDKs or third-party libraries you're including, but we always recommend that if you're going to incorporate something like that, like Keith said, to make sure you're testing those in advance to make sure there's no high-risk flaws.
The next issue that we're looking at is called code tampering, issue number 8. And code tampering refers to attackers tampering with or installing a backdoor on an app, re-signing it, and publishing the malicious version to third-party app marketplaces. And a really good popular example is Pokemon Go. And at first, Pokemon Go, which went viral very, very quickly and racked up a lot of downloads, it appeared that one of the issues was the app's overzealous request for permissions. However, another security concern brought to the surface by Pokemon Go involved counterfeit versions of the app in marketplaces where the app wasn't yet available. So users in countries where Pokemon Go hadn't yet officially launched sideloaded the app from unofficial sources and put themselves at risk. And we created a summary of that, but essentially DroidJack software, which is a remote access tool, started popping up on third-party app marketplaces around the world. And so one of the best practices is to implement anti-tampering techniques to your app. So these essentially prevent illegitimate applications from executing, and that best practice outlines those techniques there.
Great. This next best practice, as opposed to some, not best practice, I'm sorry, OWASP Top 10, as opposed to some of the other categories, which are actually pretty specific in terms of issues in mobile, this is more of a higher level category that I'm actually glad that made it into this version of the release, or will hopefully make it into the official version of the new OWASP Top 10, and that's reverse engineering. So reverse engineering refers to the analysis of a final binary to determine its source code, libraries, algorithms, and more. And the reason that I like this being in here is because as a security analyst, you do have a checklist of things that you always test for, but then there's always that certain amount of time that you set aside to just kind of hacking away at the application. And when we do our app testing, we have a couple analysts that are specifically focused in this area. Reverse engineer the app, do some code analysis, and just kind of hack away. So when you find issues in this area, I like that we have this kind of generalized category of reverse engineering to tie it back to. And it's a really crucial part of doing app testing as well. An example that we have here is with Tinder. So hackers decompiled the mobile app and recompiled it so that they didn't have to pay for premium content. We're going to get into some best practices in a minute here, but things to avoid this would be to make sure to do tamper detection to make sure that it's not being hacked. But in this case, that didn't happen. So basically, somebody was able to download the binary, decompile it, take a look at the code, modify the code, make it behave in a way that they wanted it to, and recompile it. And that's certainly something that's possible in apps across the board, and there's things that should be done to avoid it. So moving forward to our best practice here, we have it's a pretty big best practice. There's a lot of meat in it once you dig into it more, but it's increased code complexity and use obfuscation, and one of those specific recommendations within this best practice is anti-tamper techniques. So do some checks in your application to check and make sure that the app, if it's recompiled to make it behave in a way that it shouldn't, you won't let that application run on a device. So I highly recommend looking at that best practice further. There's a lot of specific items in there that can help a developer avoid these common mistakes.
And this brings us to number 10 of our 10 risks from OWASP, extraneous functionality. And this refers to developers frequently including hidden backdoors or security controls they don't plan on releasing into production. And this error creates risk when a feature is released into the wild that was never intended to be shared. And we have an example here from a Taiwanese chip maker called MediaTek. And well-known researcher Justin Case discovered a backdoor that allowed complete remote access on Android devices. The issue was compounded, one, by the company lacking any support for submission of vulnerabilities, but what users experienced was that their devices were compromised and told to stay off the internet until a patch was released. And this happened because a debug tool left open for carriers to test network connections was left open on shipped devices. And essentially, there's a handful of best practices here, but one of them is carefully managing debug logs and being careful not to include code or functions that aren't used in production. And Katie, maybe you can speak to what you call clean coding practices here and how people can improve that in their apps.
Sure. Yeah. Just generally, some apps we look at, we'll see, like you mentioned, there's unused code that's maybe commented out or maybe not commented out, but actually not called within the application. If you start to include code snippets like that aren't used but are still included in the binary, it can basically lead to messy code, and in some cases could have contradictory actions. An example I can give is we've seen implementations of certificate validation, properly checking the certificate to make sure that data can't be intercepted through a man-in-the-middle attack. But then there will be another piece of code that kind of negates that implementation. So just making sure you have, for lack of a better term, clean coding practices, and that you're using everything that you're including in your code.
Great. Well, Katie, thank you so much for being a part of today's webinar. One of the things we'll be sharing with everyone after this is our official OWASP Top 10 for 2016 checklist or quick look file here. So from 1 to 10, a quick summary. And we also have a lot more resources on the NowSecure blog. If you go there now, you'll see some resources specifically around secure authentication as well as authorization from especially one of our guest bloggers, Evan Rose, who focuses on those issues when building mobile apps. We also want to reference our secure mobile development best practices. So this is a free guide of now more than 50 best practices for secure mobile development with code snippets as well as other important resources. And we'd also invite you and your team to follow this resource, which is hosted on GitHub, as well as consider contributing if you find a new resource that we don't have, or as well as making other resources better. We're excited that a lot of members in the community share their insights and their coding best practices with us, and we're able to review and publish those there. Our goal is to end the webinar in about 25 minutes, and we're just about there now, but we do have time for questions if you're able to submit those in the box that's available to you on the right side of your screen, and I think we have one or two that have already come in. One of the questions that we have, go ahead, Katie.
Oh, sure, I was jumping ahead of you and looking at them. I can go ahead and start going through a couple of them and give you folks some more time to submit your own. One of the questions was around the Tinder app we just mentioned. Was the Tinder app that was hacked an iOS app? If so, how did they reinstall it on their device? Honestly, we don't have the full details. In the article, it does mention iOS and Android, but here's what I suspect. I suspect that this was done on Android, and if they're claiming that it's true on iOS as well, it was probably done in a different manner than reverse engineering, decompiling, and recompiling. On iOS, usually when things are done, especially on our end, we use a tool such as Cycrypt to do what's called runtime analysis. So as opposed to recompiling the package, reinstalling it on a device, and making sure it can run, you basically kind of modify the app behavior at runtime using a tool like Cycrypt. Keep in mind that things like this usually require a ton of expertise, full privileges on the device that you're testing, so it has to be jailbroken or rooted, and the app basically has to allow you to do things like that. So this wasn't a vulnerability we identified, so we don't have the full details on it. If you guys, you'll get the slides after the call here. You could link out to that article and get some more details there. But it didn't really get into the technical details on whether it was iOS or Android. Another question here, I think we answered, but are the slides going to be available afterwards? Yes, absolutely. We'll be sharing these out. And a third question is, are there any areas of mobile app testing that you don't think are covered in the top 10 categories? As with anything, I think the mobile top 10, it's constantly changing and improving. I would say much earlier versions were lacking in some areas. I think they were adapted from web apps to mobile. So the first top 10 that were released, maybe we're missing a couple categories that were specific to mobile. But I think I know the OWASP community recognized that, and they've made some really great changes this past year. And what we walk through today is the draft of the most recent top 10 that I believe is currently just a draft and not a final release yet, so they're probably still making some tweaks. But I believe they've generalized some of the categories to be more encompassing of mobile-specific issues, and I'm really happy with the changes that were made.
Great. Well, thanks so much for everyone who attended, as well as those that asked questions. As a reminder, we'll be sharing the slides as well as the recording, usually within 48 hours, but usually much sooner. And thank you so much for following our webinars. We also recommend following the NowSecure blog at nowsecure.com/blog, as well as other resources throughout the site. Thank you so much and have a great day.